Well, today I'm going to talk a little bit about the public land survey system, how it relates to conservation of soils, and also maybe talk a little bit about the role of the land-grant universities, because they are really part of all this. So some history today, and if we have time, we'll get into the the emergence of conservation as a governmental responsibility. Okay, but we start with, I've often included the discussion of the public land survey in this course because generally we generally focus on the United States, and most of the United States outside of the original 13 colonies and Tennessee and Vermont and Kentucky, most of the rest of the country, Texas is kind of an exception, and Louisiana is a little bit of an exception, are gridded in a system that was developed during the 1780s. Thomas Jefferson did a lot of different things. One of those things was he was very early, actually, kind of before his presidency, he was tasked with a plan for distributing the public domain. The public domain being the federal land that, or the land that the federal government, and at this time in 1784 actually was when he was working on this, we were a confederation, okay, of powerful state governments, and the federal government was very, very weak, had no money, couldn't tax, so it had no revenue, and that really wasn't much of a concern during the early days of the Confederation Congress. But it would become a problem after the Constitution was ratified in 1789. So the Constitution was pretty much authored by end of 1787, and then it went through a process of ratification. And one of the holdouts was New York, and New York had to ratify it for it to pass. Anyway, prior to that, Jefferson tried to come up with a way for the federal government, what they used to call the general government, or what we might call the central government, but it's the overarching federal entity that shares sovereignty with the states. And the Constitution was ratified largely by making deals between the federal government and the states. The states had debt, and the states wanted to have that debt relieved by the federal government. The federal government was willing to take it on, but it didn't have a way to relieve the debt. So what it did was it exchanged the western land claims of the various new states, and many of those land claims extended all the way to the Mississippi River. Most of them did. And so what the Constitution allowed was, the deal making prior to that was that the federal government would relieve the states of their debt. In return for their debt relief, the states would cede all of their western lands to the federal government. And that became known as, federal lands, but it became known generally as the public domain. The public domain. And the public domain was basically created to be sold to American settlers. Initially, the idea was farm settlers would migrate beyond the states, purchase land for farms, and improve that land. But essentially, the public land survey wound up being more of a system that caught up with settlers. And a lot of settlers basically claimed land without paying for it. And once territorial status was created in an area, then the territorial government would basically require them to take it. And they often took land through what are referred to as preemptive rights. So that if you were there first and you possessed the land, you had the right to claim it and had to file on it to get a patent on it from the United States. So what we're going to talk about here is the system that was created to survey the land in order to sell it. But between about 1790 and the Civil War, most of that land was not sold in the way that the federal government had earlier intended. Most of the land was claimed, and then sometimes it was sold. Sometimes it was sold in large chunks, as in western New York. But a lot of times the federal government's intentions were just not met. And land sales themselves were never very good for financing the operation of the federal government, particularly in the 19th century. Well, what it did, however, was it created a grid that would allow the federal government to liberalize its land disposal program, that is, the selling off of the public domain to individual citizens. And so this system allowed that to happen rapidly, and it culminated with the 1862 Homestead Act. It became known as the first Homestead Act. And that Homestead Act promised citizens loyal to the United States, and it was during the Civil War, so it was only good for northern citizens, not the Confederacy. Those citizens could basically claim 160 acres of land, and if they lived on it for a period of 5 years, then they could file with the General Land Office, which is a branch of the the Department of the Interior. General Land Office would then issue them a patent to the land. So the Homestead Act was the thing that really accelerated Western farm settlement, particularly in the Middle West and the Great Plains. And as the farm settlers expanded westward, agricultural development expanded with it. But in a sense, what this did was the system was designed to allow people to claim land without actually visiting the land. It also provided a neat and tidy way of keeping records of land exchange, land turnover, changes in property ownership. It created up to this time, I should precede this, up to this time, the way that people would claim land, like on the frontier, before 1785, would be to, they would establish boundaries, territorial property boundaries, by using identifiable features on the landscape. So things like trees, boulders, creeks, water channels, crests of mountains, high points, whatever. Those were used for boundary designation. And those, of course, were not regular. So the pattern, and I'll show you some examples of what the pattern looked like after in what's referred to as the meets and bounds system. So this created the U.S. Public Land Survey created a very uniform grid that basically disregarded terrain. So it abstracted the land, and it created a pattern of farm settlement that still exists today, and is one of the reasons why agriculture is the way it is in the United States. Okay? Well, here are Jefferson's intentions and his plan, and the federal government early on, Congress. They intended for the land to be, if not free to actual settlers, to be cheap, because they wanted to avoid the practice of large, very wealthy interests, whether they are individuals, families, corporate entities, whatever. They wanted to prevent land from being taken up by speculators, okay, or what we might call today investors. They did not want the land to be held by investors. The reason for that is in colonial New York, much of the land around the Hudson Valley had been distributed to, had been taken up by land speculators, or actually some of it was designated to the aristocracy, and it wasn't developed in the way, as rapidly as it could have been. Anyway, certainly Jefferson had ideas about what productive land use was, and his idea, of course, was to get farmers into the territories, into the frontier lands. His idea of democracy was one that was local, and that there was government by the people locally, and that was most important. So he wanted people to be scattered about on the landscape. The term township is used within the Public Land Survey today. We still use this, but I want to express what that means. The term township actually comes from much earlier New England settlement. So if you travel to New England, you'll find in places like Massachusetts, states like Massachusetts, you'll find that there are counties, and then within counties there are townships, and those townships are typically the local precinct or municipality. So a township is actually something that's fairly spread out. It originally included an area of farms. It was not an urban settlement necessarily. Sometimes it included urban settlements. But it was not a regular size. There was no particular geometric shape to it. But the term township was adopted in this Jefferson system. Jefferson liked it because in New England, it was the basis for most of the democracy there. The townships had meeting houses, they had town halls. The town hall meeting originated in New England, and the town hall was the center of this geographical area of rural countryside. Jefferson was an early user of the metric system, and interestingly, his division of townships is based on tens. It's based on his township would have had 10 geographical miles by 10 geographical miles. Geographical mile is a little different than a statute mile, which is what we use today. But when it was, that would eventually disappear. One of the most important things that the Public Land Survey did once it was introduced was it eliminated or at least reduced the amount of litigation over property boundaries. The meets and bounds survey system was one that was prone to boundary disputes, or at least we say property line disputes. Okay, farmers would say, no, 50 years ago when your grandfather laid out this farm, the boundary started here, and now you're saying it's over here. So there were property disputes, and most of those property records were held in courthouses, and courthouses were they're almost always built out of lumber, and they burned. So you would lose these records. And so there was all sorts of issues with property litigation. between landowners. And Jefferson's system mostly eliminated all that. Congress eventually adopted Jefferson's model, but they made some changes. They didn't like the idea that land would be free to anyone, any farm settler. So they actually put a dollar amount on the land, and for a long time that basic government land price was $1.25 an acre. Right, and that's of course not adjusted for inflation or anything, but the land was to be sold and to fund the federal government. So Congress made sure of that, and then they threw out the Jefferson's metric system, and they went to a system of 6 statute miles rather than geographic miles. So 6 statute miles by 6 statute miles. So the resulting township would be how many square miles? 36 square miles. Very good. Here's an example of a township, and not only were the squares of 6 mile by 6 mile squares, not only were those called townships, but the vertical, or what we might call the longitudinal boundary used to enumerate townships was also referred to as a township line. Okay. The east-west lines, so this is a grid placed down on territories. East-west lines were generally referred to as the ranges. So a township, in this case, I hope I got it right here, 2 south. Okay, so if you count on the township line, 1, 2 south, all right. Range 3 west, 1, 2, 3. Okay, then you get this township. Okay, this township would then be township 2 south of the range line, and 3 west of the township line. The township line took on a special name. It was referred to as the principal meridian. Principal meridian. And the east-west line was referred to as the baseline. Baseline for the measurements north and south. Principal meridian for the measurements west or east of that line. So every new territory would take on a new meridian, principal meridian, and would have a new baseline. It wouldn't necessarily be a new one. It might just be an extension of a previous existing one. Okay. Now, within the particular 6 by 6 township, if we blow that up, each township was divided into what we call mile sections, 1 mile by 1 mile. That's 1 statute mile by 1 statute mile. The numbering system of those 36 sections, 36 1 square mile sections, began in the upper, I guess we would call the northeast quarter, the northeast corner of the township, and was numbered in a sort of a zigzag fashion this way. It's always numbered zigzag. Okay, why might that be? By doing that, when you're looking at a number of a map of all sections, you're not going to have the same number touching at any point. Anyway, this particular township, let's call it Henry Township. That's the township where I grew up, out east of Stillwater. I don't know who it was named after. But if we select a section out of Henry Township, or Township 2 South, Range 3 West, then that particular mile section is referred to as Section 14. right? Section 14. And because it's a square, that section can be easily divided up into quarters that we call quarter sections. All right? So here's another example. In Oklahoma, we have the baseline that runs right through the Arbuckle Mountains, kind of around Davis, Oklahoma. And the center point, excuse me, what we call the initial point where the counting begins. So this little square here would be what? Township 1 North, Range 1 West. Okay? This one would be Township 1 North, Range 1 East. Township 1 South, Range 1 East. Township 1 South, Range 1 West. Okay? So those 4 little townships there. And so we number all the way up and all the way over. And in the case of Oklahoma, we have the state of Oklahoma has 2 meridians. The most important one, or the one that most people measure off of, is referred to as the Indian Meridian. Okay, so if you've ever come into Stillwater from the west, from Highway 51, you may have seen a big blue sign on the south side of the highway that says Indian Meridian. All right, you ever see that? Okay, so that's a marker for the meridian. There are other markers. There's a marker down in Langston that's a really cool marker in the middle of a road. It's actually the intersection of 2 section line roads, and there's a big stone monument to the Indian Meridian. In most of Oklahoma, though, they stop at the Panhandle. So this is a line of longitude known as the 100th meridian. Okay, the 100th meridian is the extent, the western extent of the townships that are north of the baseline and west of the Indian Meridian. And the other meridian is this line of longitude, which is 103 west longitude, and it's called the Cimarron Meridian, and it counts everything east. So there is nothing west of the Cimarron Meridian. There's only east of the Cimarron Meridian. And there aren't many townships within it. Okay, let's look at an example of, this is another example of a township with ranges. Here's a better example of dividing up townships. You don't need to know all the details of this, but just keep in mind that one township measures 6 miles by 6 miles, and each mile section is 1 square mile, or in terms of acres, anybody know the number? 640 acres, okay? So 640 acres is 1 square mile. In the Homestead Act, the Homestead basically allowed people to claim 160 acres, or 1/4 section of land. Okay? 1/4 section. So that would ideally create 4 farms per square mile, which is, interestingly, usually counted as the frontier. Okay, if you have 4 people or more per square mile, it's often considered settled. But in this case, you're going to have more people than that, of course, if you're talking about family farms. Now, 160 acres in 1862 was a lot of land for a farm, depending on where you were, of course. If you had 160 acres in western Nebraska, it might not be enough because you probably won't be growing crops from dry land agriculture. Anyway, so generally that was a decent amount of land in the 1860s, 1870s, 1880s. But over time, that farms needed to grow, right? Because mechanization in the 20th century and farm size to be viable had to get larger and larger. So let's look at a landscape, an idealized landscape right after settlement, or let's say maybe 20 years after initial settlement. Here's a sort of a diagram that shows sort of the farmstead. The farmstead would include a farmhouse, outbuildings like barns and chicken houses and so forth, hog sties, a garden perhaps. So this is designating the land that the farm family has to have for living, and then around them are going to be different types of cropland or pasture or whatever. So these thin lines are idealized as property lines, and the section lines are generally going to be roads. And those roads were improved greatly during the Depression. They were mostly aligned and became more of a grid. But by allowing people to claim 160 acres, and then as generations went by, they typically would divide the farm or sell it off to others, so that the 160 acres sometimes were divided a little bit more. In this case, it looks like it would be kind of consolidated, because in this particular mile section, you have only 3 property owners, right? Originally, you probably would have had 4. This one, this one has probably consolidated a little bit. So farms get larger over time, and fewer farm families are needed, or at least are capable of owning one land. Here is an actual, what's referred to as a plat map from, let's see, I think I pulled this from around Enid, Oklahoma, if I'm not mistaken. But this is an actual plat map that you can find if you dig around in the library somewhere. You can see the section numbers, obviously. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12. And the quarter section lines are mostly still apparent. And then within that, each one of these polygons is one parcel of land owned by someone. And the little black square here is indicative of the farmstead of the house, typically. And here is the name of the owner. And it's not the renter, it's the owner. So somebody rents the house and farms the farm, as a renter, then they're not counted here. And then the number of acres is indicated. Number of acres of the parcel is indicated underneath the name. Okay. So could you all be able to make sense of all that on a test? There's a cemetery. That's kind of interesting. Symbol for a cemetery. Look at this down here. What happens?
Change in township?
No change in townships. Well, there's a, here's a town.
Change in municipality or county?
Okay. Well, look at the land parcels right here. What's going on?
It really gets tight. I thought you were talking about the really heavy dotted line.
Oh, yeah. Well, that's actually railroad, I think. It says the Chicago, it's like a trunk line railroad, and here's just a spur railroad. So they have different symbology.
So that's probably like a town.
It's a town, exactly. And some of the land, some of the parcels of land are so small you can't see them on the map. So it basically, these have been divided up into town lots. So you can't see that on the map, although there's some symbology for churches and schools. Okay. Anyway, so this is kind of sort of a record in time. I'm not sure exactly from when this was taken. You can see RFD. What's that refer to? It could mean rural fire district. Okay, that's my guess is what it means. Rural fire districts are all over the state. Boundary line for the rural fire district. Anyway, so that's an example of land ownership in an actual place here in Oklahoma. And like I said, over time, what is there to know from this? essentially what there is to know from this is that settlement is dispersed, number one. Farms are dispersed. And that's nothing new to you, obviously. Because of the distribution of the Homestead Act and the things, the initial settlement, property lines follow right angles, almost always. So it's really easy to divide up land based on, for example, if D.P. Variki has 120 acres and 3 children, and he wants to leave an equal amount to each one, everybody gets a 40-acre parcel, okay? What's referred to as a quarter of a quarter, because he has 120 acres there. So, so the land parcels, even when they're subdivided, tend to follow the right angle thing. And so what's a big deal about that? Well, number one, it disperses settlement. Number two, the parcels, the properties themselves completely ignore the topography of the land. Okay? This could be very hilly land, but yet there's no accommodation to slope. There's no accommodation to land that can't be farmed, etc. You could probably guess, if you look over here, you can probably guess this is probably really good land. And this might be not so good land because it's still in one chunk. But this has been divided up, perhaps, just a guess. So the main thing to remember is that the Public Land Survey was good at distributing land to American settlers, dispersing agricultural settlement, so that American agricultural settlement would be almost unique in the world. The only other place in the world that has a similar sort of settlement pattern is South Africa. All right? But most of the rest of the world, especially Europe, and throughout the world, farm settlers or farmers typically will live in some sort of clustered community, whether that's along a water body or a river or a creek, or whether that's along a road, or it might be a village that surrounds a green area, as in a green village in England. And the common thing for hundreds, if not thousands of years, was for these farmers to live in basically small villages and to know their neighbors very closely. All right? And during the daytime, they went out to their fields. In some cases, if they had, if they're pastoralists, they had cattle or something, or goats, and this still happens today. A lot of times, the village itself was sort of the protection area for livestock. So you brought the livestock into the village green at night, so the predators wouldn't hit them, and where they were protected, and then you would take them out in the daytime. Our ideas of sheep herders, or what do you call them? Shepherds. Yeah, our idea of shepherds follow a Middle Eastern model of that, where shepherds went out into the wilderness during the day and watched their flock and then brought them back in the evening. So American settlement is really unique in the world in that it dispersed people across the landscape. Jefferson is largely responsible for that, Thomas Jefferson. How did that affect social development in the rural United States? Well, people knew their neighbors typically, but they didn't live in clustered communities. They didn't have the same sense of community and responsibility to the community that most people elsewhere in the world did. This was an individualist society, and the settlement pattern of the country itself tended to promote a sense of individualism. what we call rugged individualism, the ability that there's a nuclear family, or that nuclear family, when the children grow up, they go somewhere else. All right, probably enough on that. Here's a map of the United States and the principal meridians and townships, so forth. Here's the odd panhandle of Oklahoma. Here's another kind of odd one. But you see, Texas. Why does Texas not have a system here? Well, I said Texas is kind of an exception. That's because when Texas was annexed by the United States in 1845, it joined the Union as soon as it could. In 1845, Texas came into the Union, and Texas had its own sets of surveys. Some of the land down here was surveyed by the Spanish, and some was surveyed by the French, most of the time under the same regime. So there are different types of settlement in Texas. And then Texas basically adopted a system very similar to the township and range system for most of its western territory. So, but one of the things that when Texas came into the Union, it had already started surveying, for one, but it also had a lot of unsettled lands. What happened to that land? Well, remember that in the original colonies, gave their western lands to the federal government. Texas had that option, but it decided not to do that. Instead, Texas said, we're not going to hand any land over to the federal government. We're going to keep it for ourselves. And so today, even to this day, there's really not much federal land in the state of Texas. There's certainly no public domain as there was throughout here, at least not federal public domain. Okay, here's an example of the township and range system in actual places in Ohio, and this is prior to the public land survey system being adopted. Northeastern Ohio is where they did this. So you can see that property boundaries are not anywhere close to regular, although the parcel shapes, size of parcel may indicate the quality of land. Who knows? Here's what we start off with, and then over time it gets subdivided and subdivided. And then today, like I said, since the 1980s, most land has been consolidating, so that there's fences are being torn down in much of farm country because of the consolidation of farms and land. Wow, okay, what a transition that was. There was no transition. There was abrupt change in things. Now for something completely different. Let's talk a little bit about soils. Perhaps you've had a soils class. There's a real good one here in the College of Agriculture. This is sort of the basic stuff that we would cover in physical geography class. So number one in my class, don't ever say the word dirt to refer to the stuff that we grow crops from. Okay, dirt is what's underneath your fingernails after you finish working all day. Anyway, soil is made up of a number of things. It's made up of crushed parent material, whatever the base or whatever the base rock was. So in this part of the world, in Oklahoma, or this part of Oklahoma at least, what is the base material, or the parent material for most all the soils, except for maybe the ones in the Cimarron Riverbed and close to that. Now, soils that develop in place have a certain name. They're referred to as residual soils. And soils that you find maybe along a river, in a river valley, that have been deposited by floods, are referred to as transported soils. So in this part of the state of Oklahoma, in Payne County, the residual soils reflect the underlying bedrock, and that underlying bedrock here is, anybody know? Sandstone. Permian sandstone. Permian red bed sandstone. Okay? So if you ever hear anybody refer to the Permian red beds or the Permian soils, it refers to those. Some people say red soils, but I tend to say orange soils. You know, they look a little oranger to me than red. You get closer to Norman, they get redder. Maybe you're grinning. I don't know. Can't see for the mask. Well, anyway, the parent materials are generally infertile. Okay, but the parent material is really significant. Well, of course, for providing minerals, but parent materials are really significant in the sense that different types of rocks, igneous, sedimentary, metamorphic, whatever, have different properties, and they break down differently. They break down at different rates, and so they produce soils of different textures. It's mostly associated with the texture of the soil. Some of the very best soils in the world have parent materials of basalt, or what you might call lava rock. That's basically a softer rock. Well, it's not necessarily soft, but the rock that was formed from cooling volcanic lava. Okay, and so volcanic soils, especially those that are the result of volcanic eruptions and ash falls, are usually very good soils. We don't have a lot of volcanic soils in the lower 48. There are some up in Washington State, for example, eastern Washington State. The eastern part of the state's very dry. So it's a wheat farming country, and it has fantastic volcanic soils. But most of the really good soils in the United States are limestone-based soils. Okay? The limestone, as you know, is limestone. That's the point of the sandstone. Limestone, as you know, is water soluble. Okay? It breaks down quickly with water. So if you like to go caving, exploring in caverns and stuff, most of the time those are going to be limestone-based caverns. Right? Now here in Oklahoma, we have. Have any of you ever been to Alabaster Caverns? Alabaster Caverns out in Woods County. It's near Freedom, Oklahoma. It's a cavern system that is developed out of gypsum, basically different types of gypsum. And when you get really pure gypsum, it can form this thing called alabaster, which is just kind of a popular name for a rock.
Where's that near? In the general context, we're about its Freedom, Oklahoma.
Northwest, sorry, yeah. Yeah, you know where Woodward is? Okay, Woodward, it's sort of northwest of Woodward. Yeah. Or actually north of Woodward, I guess. Sort of west of Alva, right? West of Alva, north of Woodward.
Kind of close to the Panhandle.
It's getting there. It's not real close to the Panhandle, but it's getting there. Yeah, it's definitely northwest Oklahoma. All right. Certain types of so lava and limestone are very, very desirable types of parent material. There are other types of parent material, granite and sandstone. Of course, granite's extremely hard, and most of the time the residual, soils from granite are sand. Okay, quartzite. So sandstone is a sedimentary form of that, but it's usually infused with other things. So around here, sandstone is the bedrock. Sometimes it can be ground up pretty finely, and it makes for decent soils. So those are residual soils. Transported soils are those that have been moved and deposited. and they are almost always fertile soils because they have been mixed with many sources of parent material. Okay, and the great civilizations, we talked about this when we were talking about population. The great civilizations of the world arose from river deltas and river valleys. The Nile Valley, for example, is the Nile Delta is especially fertile because for eons the transportation of the soils were coming from all over East Africa. A lot of those were volcanic soils too. So it was depositing all of this mixed stuff into the delta. So we have a variety of soils in Oklahoma. Most of them are residual. Okay, most of the good ones are residuals. Or most of them are residual. We have some good depositional or transported soils also. All right, now let's talk a little bit about soil conservation. All right, about time, right? Soil conservation. And I want to talk a little bit about sort of the legacy of soil conservation in the United States, the history of it, if you will. We've talked about George Perkins Marsh, right? And he grew up in New England and Vermont. And for New England in general, although most people love to visit, it's a beautiful place, especially this time of year. Quaint little towns, lots and lots of trees. It wasn't always like that. They deforested New England pretty early on. Farms were scattered about since the 1600s. But New England itself was never very productive agriculturally. The only exception would be perhaps grazing cattle and maybe producing dairy products. But agriculturally, New England was always outcompeted by states to its south and west. Not only did it have lousy soils, thin, stony soils, it also had the worst climate for growing crops. It was incredibly harsh in the winter. It didn't get that warm in the summer. Okay, so agriculture was never a reason for people to go to New England. It was, the Puritans who arrived in the 1600s early 1600s were not farmers; they were city people. Although they did do some farming eventually. But their economy gravitated more toward the sea and toward trade. And over time, as New England farms were outcompeted by those of the Middle West, farms were largely abandoned. You can walk through forests, what you would think were primeval forests in New England, and find old stone fences that were constructed 200 years ago when the place didn't have any trees. If we go a little farther south, Virginia, Maryland, Kentucky, North Carolina were areas of tobacco production early on, and the plantation production that produced the tobacco economy essentially required felling trees and in opening up new fields. Tobacco, like corn and cotton, are row crops, and they have a large degree of they take a lot of the fertility out of the soil quickly. So tobacco was a crop that was worth a lot, but there was a large cost in the soil, a large cost in the fertility of the soil. Not to mention that it was a row crop and it created a lot of erosion. So the tobacco farmers in Virginia were very interested in western lands because their lands often played out over time. They didn't practice soil conservation in the way that we understand it. And so they had to open up new lands all the time. Same thing was pretty much associated with the cotton production economy beginning around 1800 in the Carolinas and Georgia. Lots of erosion problems associated with row crops. Have you ever heard the term chopping cotton? What do you think that means? It doesn't mean harvesting cotton, because you harvest cotton by hand. You pull the cotton out of the cotton bolls, and you usually do it 2 or 3 times. Okay, so chopping cotton refers to weeding cotton with a garden hoe. All right, and chopping cotton was the great, generally the large amount of labor, other than picking cotton, for slaves during the slave economy. Later on, after the Civil War and abolition, the cotton farms of the South had basically family labor. So the family labor was usually minimal, and so crop or farm size tended to shrink for a while in the South. Oklahoma is kind of an interesting example of the expansion of the cotton economy back during the late 19th century and early 20th century. And mostly because of the crops that they grew in eastern Oklahoma and southern Oklahoma. The row crops were primarily cotton and corn. There was an enormous amount of erosion. And perhaps even more so, most of the land was not owned by non-Indians who were farming it. They were renters. They were generally sharecroppers or renters. So that meant that they cut corners on conserving soil. That is, they didn't practice what we would consider sort of common sense soil conservation efforts, like plowing perpendicular to a slope rather than or horizontal to the slope rather than perpendicular to the slope. Now in Pennsylvania, there was sort of some different patterns. The people who came to Pennsylvania, many of them were from the German-speaking lands of Central Europe. And they brought in practices of livestock manuring or livestock husbandry, in which they collected manure from their cattle, allowed that to compost, and then spread it out onto their fields. These practices would then be picked up by most other Americans, especially in the upland South, people who settled this part of the country. All right, now, in conservation and soil conservation, you'll run into this term, and we've talked about sustainability and that sort of thing, but it applies to any renewable resource, obviously. In the case of soil, we think of soil as a renewable resource. Okay? Soil can be damaged, it can be lost. So a lot of times when people are referring to what we used to call erosion, like whether it's fluvial with water or aeolian with wind, erosion is basically soil loss. Soil loss. Loss of topsoil, put it that way. So a yield that can be had continuously at a given intensity of management without harming the environment is what we might call a sustainable yield. Now that means that you're going to have to be careful and not overexploit the resource. In the case of soil, the best example of overexploitation of the resource took place, that I know of, in Oklahoma. And it took place over the course of about 30 years, from well, actually more than that. Actually more like about 50 years, beginning in the 1870s, if you really take it back. But by 1890, 2/3 of Indian Territory were non-Indians. And they were largely farming land that they were renting from Indian allotees, Native Americans who had received individual parcels of their reservations. So the reason that we had so much erosion was because these people didn't have property rights, right? They did not share in the property rights of the land that they were farming, and they weren't necessarily going to be in the place forever. So many of them cut corners, tried to get as much profit as they could off the land, and that sometimes meant cutting corners and not thinking long term about soil loss. So when we talk about the loss of soil or soil erosion in Oklahoma, most everybody begins thinking about 1931 through 1937, the Dust Bowl days, right? Well, the Dust Bowl was significant. It was a major period of soil loss, but most of the Dust Bowl area, the area that was affected by the drought and wind cultivation, was located far to our west. Okay? Much of the erosion that hit Oklahoma, that spawned a federal program to try to fix the erosional problem, most of that erosion took place in the 19-teens and 1920s when we had wet years, we had moist years, and most of that erosion was located in southern and eastern Oklahoma. I don't think you probably just say central Oklahoma and eastern Oklahoma. So, and it was erosion from water, from fluvial processes, from rainfall. Okay, let's see here. I'm going to skip over this, and we might come back to this. Actually, let's look at this. The soils are one of the most intensively mapped natural resources we have. Soil scientists use a sort of a theoretical parcel of land known as a pedon, and notice that it's theoretical. It's a theoretically hexagonal shape. Okay, hexagons fit together without any spaces in between, and they're sort of equivalent to circles. But anyway, the general soil pedon measures about 1 meter in diameter, and basically this is a way of when you sample a profile of the soil with a core, then you're basically making you're creating samples that will eventually allow you to sort of draw a map on the different types of soil. So you don't need to worry too much about all this. Don't worry at all about this stuff. Soils have different profiles, and so soils are classified in many different ways. They take on all sorts of names. Names are generally associated with something locally. You may look at the name and have no idea what it means, but it's basically a categorization of different qualities of a soil profile. Okay? Now, within this individual pedon, this individual sample, the soil profile is everything between the surface and the regolith, or the parent material, down here. So a soil profile has these various, and it doesn't necessarily always have all of these, but any soil profile is going to have an O horizon. These are different horizons of the soil. An A horizon, and then whatever, it depends, but what's going to be there. based on how the soil has developed. Now, what are the factors that go into developing a soil? Obviously, the parent material we've talked about. Okay, the surface, the O horizon, and there's actually some other ones, but the O horizon is the one we want to pay the most attention to. The O and the A horizon. Let me see if I can get a better example here. This is a schematic that shows how soil develops over time and the different processes associated with it. So basically bedrock breaks down by physical weathering, it breaks down by chemical weathering, reactions like the reaction to water that limestone will have. These gravels and silts and stuff eventually break down. And then we have different types of chemical and physical weathering and what's referred to as pedogenesis. So this is the development of the actual soil. And most important in that are the organic materials and even the organic organisms. Okay. Soil is not only a renewable resource, it's in many ways a biological resource, because soils are always going to be containing, most of the time, worms, okay, earthworms. They're going to be containing bacteria and all sorts of fungi and maybe insects. Those things break down the parent material. They break down the organic material that falls onto the surface in the form of dead grasses and leaves and any sort of litter. And over time, that O horizon, that organic stuff, will break down. How does it get down into the rest of the topsoil?
Through things like rainfall events, it seeps down.
Yeah, exactly. That vertical movement of the material with water is referred to as leaching. So the materials leach down into the topsoil. That means that if you get way too much rainfall over a long period of time, also temperature is a factor, okay? So temperature is going to determine how active the organisms are, especially the bacteria. In this part of Oklahoma, right, we have a distinctive warm season and cool season, and we have differences in rainfall at different times of the warm season and cool season. Right now we're in late September, early October. We're in our secondary peak of precipitation, and it's a cooling off period. Well, that's different from getting a whole bunch of precipitation like we usually do in March and April. And it's still kind of cool. All right, so the combinations of temperature and precipitation, slope, bedrock, the combinations of those, the breakdown of organic items on the surface, all of those go into the development or pedogenesis of a soil. Soil textures are measured with something called a soil texture triangle. And if you were to take a lab course, then you would have fun with all this. But generally, what we could say is that it's sort of the Goldilocks thing. You don't want a soil that is too much of one component. On this corner, in this corner we have sand. In this corner we have silt, which is a medium scale size component. Think of it all as rock, so it's broken down as rock. So you can have sand, silt, which is smaller than sand and can be moved pretty easily by water. And then we have clay. The clays are the finest size grain of a soil. And clays tend to compact. Clays tend to be so small that they don't allow water to percolate through them. Sand, of course, is large and it has a lot of airspace between particles, so water can easily drain through sand, sometimes too fast. Silt is the Goldilocks, okay? So silt is, but silt itself is not always good. What you want to have is a mix of silt with sand and maybe even some clay to get what is referred to as a loam. But a silt loam is great. Sandy loams are great. Most of the time, if you were to go buy topsoil from a materials contractor or seller, if you go say, I want a truckload of sandy or a truckload of topsoil, they'll give you a truckload of sandy loam, which is what they've mixed between the local stuff they have with a little bit of sand. Because it drains well, but yet it's able to retain some fertility. Okay, soil horizons. Let's look a little bit closer at these. The O horizon is essentially that area that is still breaking down. It's the organic matter on top of the soil. Sometimes it's integrated enough, like sod, for example, would be the O horizon. If you're in a forest, that O horizon is going to be made up of dead leaves and rotting twigs and stuff like that. So this is where a lot of the action takes place in development of a soil, the air-surface interface. The part that we're interested in agriculture, however, is the A horizon. The A horizon is the true topsoil that's below all of the litter and stuff on top, and that's usually the part of the soil that has lots of organic matter, but it also has a mix of the weathered material, the clay, the silts, and the sands. Typically, you'll have a pattern like this. So an E horizon is just a lighter colored zone where there's been some leaching, perhaps. A B horizon, a C horizon, and then the R horizon, or the R stands for regolith, or sort of the breaking down of bedrock. But these different horizons can be differing thicknesses. They can be different orders. Sometimes there's just, there's not a lot of horizon development at all. So that all depends on all of those factors that develop a soil. Soils develop very slowly.
I think I was told in my soil sciences class that it takes about 500 years for an inch of soil to develop.
I've heard all sorts of examples like that. Yeah, I've heard 500 years, maybe 1,000 years. It's hard to say. But one thing we can say with certainty is that most of the soils in the United States were opened at a certain point, right? Not too long ago, geologically speaking. So, in this part of the country, how long have the soils been farmed? Those areas that are being farmed today. Most of the time, if they opened the farm up in like 1889, developed the farm enough, maybe by 1900. So they've been, most of the areas around here, you can pretty much bet the soils have been worked every year or almost every year for 120 years. And what does that do to the soil? In other words, what I'm saying is we have not only the soil doesn't develop just naturally. Now, in what we call the Anthropocene, that is the era of the Earth when humans are making a very large effect on the Earth, we have worked soils in some cases to death, so that the organic matter that they had when they were first tilled from sod, that quality of fertility is long gone. So what do we have to do? Well, not only is the fertility long gone and you have to fertilize, but the texture of the soil, the material texture of the soil often gets so fried and so churned that it has a very different quality now. It doesn't act the way that it did when it was first tilled. All right, well, we know about this. I'm going to skip over most of this stuff. I don't want to spend a huge amount of time on the USDA soil taxonomy. And I don't want to test you over the types of soils in Oklahoma. I don't know. Are you interested in that? We can talk about it. I don't think that's necessary at this point. But I do want to talk about the soil taxonomy that we have. Here is this is the old version of the soil taxonomy in Oklahoma, and this was redone in the 1960s, and we have something different now. But basically, I want you to know this, okay? The NRCS, what's that stand for? Natural Resources Conservation Service. It was renamed that in the 90s under the Clinton administration. Before that, it was called the Soil Conservation Service. But they expanded their activities. So the NRCS and the Soil Conservation Service today uses a 6-level classification system, and the very highest of those are what they refer to as the orders, the soil orders. These are the most general, absolutely the most general types of soils there are. We don't need to know too much more, except there are suborders, there are great groups, or subgroups, families, and series. Now the series is that local soil, and there is about, can I help you? Oh, yeah, sure. No, that's all right. The soil series today is the smallest scale classification, and there are around 15,000 different soil series in the United States. So if you're a soil scientist, you would generally specialize in a certain area, and you would know those soil series pretty well. But your students, and all I want you to know are the orders, okay? Soil orders. And in Oklahoma, here are the dominant soil orders at the scale of the whole state. What do you need to know? Well, number one, the mollisols are the very best soils, very best quality of all these, or of these 7 major soil orders in the state. Mollisols are the dark green areas of the state. The soils with the least quality would be the ultisols and probably the vertisols, maybe the iridosols. There aren't too many of those, and the intisols. But ultisols make up a large area of the Ozarks and the Ouachita Mountains. Mostly they're thin soils. They have, they develop on slopes, so they're not very good farming soils at all. Mollisols are good. Inceptisols, this is the area of the gypsum hills of western Oklahoma. So we were talking about Alabaster Caverns around here somewhere. So just keep that in mind. Mollisols are soils that develop over mid-latitude grasslands. And the great grain farming areas of the world, the United States Great Plains, the Pampas of Uruguay and Argentina in South America, the steppe of Russia and Ukraine, where they grow all the grain for Europe. Those are all areas of mid-latitude grasslands that were cultivated, and they're made up generally of mollisols. Well, that's enough, isn't it? Let's finish with mollisols, and we'll see you on Tuesday of next week. And I'll put some of this stuff up for you, but I don't necessarily want you to know all the characteristics of all the soils. We don't need to know that. Just those two that I talked about. And then we'll start off with erosion. We'll look at some erosion next time, okay? All right, have a great day.